Más o menos good, tired, sleepy, not ready for it to be a Tuesday. True that. All right, can I get a volunteer in the loudest, most boomingest voice you have to please read the lesson title and our objective, and do it super loud so that way the microphone can pick you up. Go ahead.
I will prove given quadrilateral is quadrilateral.
Get quadrilateral.
I'm so sorry.
It's okay.
Quadrilateral is a parallelogram using slope and distance formulas by drawing on
Cartesian.
coordinate plane.
The Cartesian coordinate plane is graph paper. That's the fancy proper term for we got some graph paper going on. What's the lesson title? Test for parallelograms. Basically, I'm going to hand you a four-sided thing, and I'm going to go, is it a parallelogram? And you're going to go, yes or no. And then I'm going to go, but why? And you're going to be like, bam, here's why. Okay? Let's get into it. If you like, in your textbook, this particular section starts on page 413 of our green geometry textbook, and you can use that if you would like to help you fill out the conditions. So here's what you need in order to have a parallelogram. If both pairs of opposite sides of some sort of four-sided quadrilateral figure thing are congruent, then the quadrilateral is a parallelogram. This should feel very familiar from our review from yesterday, right? Well, I said, here's a parallelogram. And you went, great, opposite sides are congruent. Well, this says, here's a four-sided shape. And you go, oh, I notice opposite sides are congruent. And I go, oh, I gave you a parallelogram on accident. I meant to give you something else. If both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. If the diagonals of a quadrilateral bisect each other, then you have a parallelogram. If one pair of opposite sides of a quadrilateral is both parallel and congruent, then you have a parallelogram. Okay, so those are the four things that you were able to check, to use to confirm whether this thing is a parallelogram or not. Okay? And at the end of the day, if I ask you, is this a parallelogram, and tell me why, I don't care which one you use unless I tell you specifically which one I want you to prove. Okay? So I'll be asking you to practice using specific ones, and then come likely end of big test time, I'll just go prove it, and I will let you choose whichever one you like the best. Okay? But for practice time, I'll ask for specific ones to make sure that you're comfortable with all of them. Let's do some practicing. We need to find the values of the variables so that FGHJ is in fact a parallelogram. And remember that if in order for it to be a parallelogram, opposite sides have to be equal. So in this parallelogram, this side needs to be congruent to this side. And this side needs to be congruent to this side. That is, this should be equal to this. And this should be equal to this. Okay? So let's solve these equations. I'm going to solve the one on the left first because it's only in one variable. You're going to see the display go black and then come back up with the writing portion bigger so you can see what I'm writing, okay? There we go. Okay, I'm going to solve this one on the left first so that I can get a value for x. And then once I have that, I'm going to use that to solve this one for y. Here I go. All right, so please double check my arithmetic and let me know if there's any lines that you're not sure of. Why did I do minus 6 here? Because I subtracted 8 from both sides. 2 minus 8 is negative 6. I did that. Yes? Okay. Thank you. Great question. What this means is in order for this thing to be a parallelogram, x has to be 2 and y has to be 3. And if there are any other values, this thing's not a parallelogram. It's something else. And if you want a parallelogram, you're not going to accept anything else. Feeling okay with this? Good. All right, let's flip the page. There are 4 other examples for you to choose from using sides or angles. Do you want to see any of these or are you okay? Do you want to see any of these 4 examples done? Or are you okay? You want to see number 3? Okay. Yeah, because number 3 seems weird. It doesn't have opposite angles because we have that diagonal. We don't have 2 diagonals, so we can't use the fact that they bisect each other. And I only have 1 pair of opposite sides for me to play with to show they're congruent. But if I recall, one of the properties that I had, one of the, not properties, what are they called? Conditions. One of the conditions was that opposite sides had to be both congruent and parallel. If I look at number 3, I could show the value that y had to take in order for those sides to be congruent. Yes? So I could find a way to get this side to be congruent to this side. But if I notice these lines, and if I extended these lines, and I want to find a way to say that they are parallel, I can make use of this diagonal as if it were transversal and end up looking at this angle and this angle, which are what kind of angles? Alternate interior angles. We got it from 2 people thinking at the same time and helping each other out with telekinesis. So if alternate interior angles are congruent, those lines are parallel. We know what we need to show are equal to each other. So let's go figure out the values of the variables. I need to show that this is equal to this. And I need to show that this is equal to this. Well, not show, but I need to state that. So if the blue and the yellow are congruent and the 2 orange angles are congruent, then the blue side and the red side are not only congruent, they are parallel as well. And that's one of our conditions. So we're going to go ahead and solve these real quick. Okay, make sure I did my arithmetic right. Feeling okay? All right. Okay, we're going to look at the coordinate plane now. The coordinate plane is just graph paper. We're going to use the coordinate plane. We're going to use distance, slope, and midpoint. My practice set here walks you through specifically formula and slope and distance, and then on the very back of it has an example for midpoint. So at the very least, I'd like to get to number 4 on the very back, so make sure that I do that. All right, so let's remind ourselves of some formulas here. What is the formula for slope? I heard it, y2 minus y1. Yep, x2 minus x1. Beautiful. Now, why would slope help? Okay. And the slope of two lines, if they're the same, then the lines are parallel. And if I want this to be a parallelogram, I need this side to be parallel to this side. And I need this side to be parallel to this side. And if I can show that, meaning the slopes of those lines are equal, then I will have been able to state that this is a parallelogram. Okay? So let's do that together real quick. I want you to make note of one thing. This is the coordinates for A. Okay? So A's coordinates, let me write it out for you off to the side. Yeah. A's coordinate is a -2, 3. Okay? That caused some issue though. The first time I did it, I didn't catch the negative, and so I was getting really weird numbers. Okay. AD. I'm going to start off with AD. Y minus Y. X minus X. 3, 1. BC. I'm just going to run through these pretty quick. So if you're not sure where I'm getting some things, please stop me.
How did you do on the first one? On the bottom?
Here? Because this is the x coordinate of D, which is -3. And this one. Alrighty, I'm done. Looks like I've got several people finishing up. Did I get the same numbers you did? Okay, so that means that I didn't, and I did that for more than one person? Okay, good. That means I didn't mess up. Alright, so are these two lines parallel? Is AD parallel to BC? Yes, because the slopes are the same. Is AB parallel to CD? Yes, because the slopes are the same. Therefore, remember 3 dots organized as a triangle means therefore. Therefore, ABCD is a parallelogram. Confirmed by using slopes. We're going to do the same thing now, but this time using distance formula. Reminder, here is distance formula. Oh my goodness, that was the longest formula in existence. All right, I need to find first the distance of AB. So I'm going to use this formula, I'm going to copy it again, and then I'm going to substitute into it, and I'm just going to do the subtractions and the squaring and the adding, and I'm going to leave it under the radical. I'm not going to go to the calculator, just going to leave it like that, because those numbers are easier for me to recognize whether they're the same or different than decimals, where I'd have to look maybe a couple decimal points in to decide. Okay, so here I go. Okay, A and B. So here's the x coordinates of A and B. And then here are the y coordinates. Don't have any double negatives to deal with. So this is -5. That's 1. Whenever you square a negative, you will always get a positive number. So if you're using your calculator and you type in -5 squared, the calculator is going to give you -25 because it thinks you want it to square the 5 and then shove a negative onto it. And what you really want is for it to take the -5 and square that. So if you're using a calculator, you have to put the parentheses. Otherwise, the calculator gets confused. Okay? Now for this part, because the rest of it is on a different page, because typesetting fail, I'm going to rip it off, and then I'm going to do the other 3 in quick succession, and then I'm going to rewrite the one I just did. Okay? But I'm going to be using the same points, and I'm going to do it fairly quickly. So you guys go ahead and do that too. It's a race. Who can get all the distances in first? You're very welcome. Please note that I'm writing everything, and I'm not, these are your notes, so if you don't want to write everything and all the substitutions, if you can think through without it, go right ahead. These are your notes. But I'm going to write everything. I know, right? I would tell a story while I did this, but I would confuse myself. And sometimes it's hard to think if people are talking. What did I do? Oh. Confused myself there. saw my work. All four sides, the distances have been calculated. One of my conditions for a parallelogram is that opposite sides are congruent. If I resketch my parallelogram very quickly with the letters A, B, C, D, that's about the same way as we had it the first time. I see that the blue side is opposite the red side. And so here is blue and red. Are they congruent? Yes, because they have the same measure. I also noticed that AD I colored in green and BC I wrote in orange, and so we're going to look at the green and the orange numbers and go, are these sides congruent? Yes, because they have the same measures, and so both pairs of opposite sides are congruent. Therefore, this thing is a parallelogram. Right? How are you feeling with using slope and using distance? It's all right. Okay. We have time, if you want it, for us to look at another example for slope or distance. Do you guys want to take the moment to do that now, or do you want to move over to the midpoint one? All right, let's ask this another way. Give me a thumb up if you feel comfortable using slope to determine if it's a parallelogram. That was, you found slopes of opposite sides and made sure that they were equal. Okay, good. Give me a thumbs up if you're feeling comfortable using distance, the one we just did right now. Okay, I've got a thumb sideways for it's a little weird. Okay, I've got a couple thumbs sideways, but mostly thumbs up. All right, let's do midpoint, and then we'll come back and we'll do another distance one. And on those of you who are feeling comfortable with distance, that will be your cue to go ahead and start on the assignment, okay? All right, so flip the page. We're looking at example 4. We're doing midpoint. Let's remind ourselves of the midpoint formula. Midpoint formula said this. The midpoint in the x-coordinate, comma, midpoint of the y-coordinate is given by doing nothing more than taking the averages of the x's and the average of the y's. Okay? First step, I'm going to graph this thing. The first example that we did, it was already graphed for us, but we're going to go ahead and graph this one. I notice there's no origin, so I get to put that origin anywhere I want. So I'm going to look in the points to have that help me decide where I should put my origin. Looking at the points, I see on the x values, my smallest number is a -3. So that means wherever I put my y-axis, I have to be able to go to the left at least 3. So 1, 2, 3, which means right about here would be okay. So that looks pretty good for a y coordinate. And if I look, the biggest number is 3, so as long as I can get to the right 3, I'm okay. To decide where my x-axis should go, I'm going to look at my y's. I see my smallest number is a 1, and my biggest number is a 4. This means I don't have any negatives on the y, so I can put my x-axis really low. So that way I have plenty of room up here in order to get to that 4. I feel your pain. All right, I'm going to go ahead and graph it. I highly, 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 highly recommend that when you're graphing your points, you immediately label them so that you know which point is which. Okay? So I'll meet you again on the other side of having graphed this thing. Now that I have the points plotted, I'm going to go ahead and take my straight edge. I'm using this little baby ruler I had up here on my desk. You're welcome to use the edge of your cell phones or a sheet of paper or hall pass, whatever you happen to have as a straight. As long as it's a straight and it has an edge that you can trace, we're good. All right, off bat, this thing certainly does not look like a parallelogram. It looks like a spaceship. I don't know. It looks weird. Does it look like y'all? Because that's my first check. Did what I draw look like yours? No. So this tells me that one of us may have graphed points in the incorrect spot. And I'm going to hazard a guess it was me. So I'm going to run back real quick and just double check to make sure I graphed it in the right spot. I'm going to use a different color in case I need to make any changes. And if I didn't, then I'm just going to be like, well, you know what, YOLO, and I'm going to leave the picture like this. Because I'm going to use midpoint formula to confirm anyway. And I don't really need it in the correct spot to use midpoint formula, but drawing it helps you see which things are the diagonals. Okay? So I'm just going to double check. 3, 3, 1, 2, negative 3 here. Oh, it was this one, negative 1, 4. Okay, it was this one. It was I that I put in the wrong spot. I went negative 4, positive 4. Okay, so I'm just going to retrace in the dark blue. Okay, so now does this look a little closer to yours? Okay, ignore the light one, you're going to go with the dark one. Does it look closer to yours now? Okay, so I feel comfortable that I did it better now than I did the first time. Certainly doesn't look like a parallelogram, so we're going to think that maybe it's not a parallelogram. But what we need to do using midpoint formula is remember that one of our conditions is that diagonals bisect each other. This means that the midpoints between the two diagonals are in the same location. Okay? So, nope, sorry. So I'm going to figure out what my diagonals are. My diagonals are going to be F and H. So there's one diagonal. And then the other diagonal is going to be G and I. All right, so those are my diagonals. Totally doesn't look like they bisect each other because we've got a long piece here and a really tiny piece there, so it totally doesn't look right. But let's check. All right, let's find the midpoint of GI. All right, so midpoint of GI is going to be x1 plus x2, y1 plus y2, both of those over 2. And so here are the x's. And here are the y's. And so the midpoint of GI is sitting on zero, 3. 0, 1, 2, 3. This is the midpoint of GI. Okay. We're going to repeat, but this time we're going to find the midpoint for FH using the same formula. F H F H. Okay, F H 0, 1, 2. All right. Are the midpoints in the same spot? They're in the exact same location? The orange midpoint and the green midpoint, are they in the same spot? No. Which means they don't bisect each other. Because if they bisect each other, They should be in the same location because they cross through each other's midpoint. Are we okay with this one? This one seems the least intuitive, and I understand that. I'm sorry. Okay, at this time, if you're feeling really, really comfortable with what we did, you are welcome to start working on your assignment. Those of you who want to see anything again, I'll be happy to run another example for you. You want a distance? Yes? You want a distance? Okay, I have someone else for distance, yes? All right, let's run distance again. Can I flip the page? Hi. Okay, we're going to look at number 2. Same process. I'm going to go ahead and plot the corners. Well, I need to find the 0. I see my smallest number is a -3, and my biggest is a +3. That means my y-axis could go somewhere 1, 2, 3 right here. So that would be a good place for a y-axis. And an x-axis. Smallest is a 3, biggest is a 0, so it looks like they're mostly negative, so I can go way up here. Okay. -1, 0, there's R. 3, 0, 2, 3, there's S. 2, -3, there's T. And U, -3, -2, there's U. Straight edge. This does not look like a parallelogram. But I'm going to use the distance formula to confirm. Distance formula checks this length against this length, and it checks this length against this length. I need both sets to be equal to each other, and the moment I have even one set different, I can stop because there's no way it's going to be a parallelogram. So you get to pick which pair of opposite sides would you like to see checked on, the blue and the red or the green and the orange. You want to see these pairs of sides, if they're congruent, or do you want to check these pairs of sides to see if they're congruent? The top and the bottom, so the green and the orange? Okay. So we're going to run distance formula on the top side and the bottom side. My x's, all my x's. I don't have to go in and do it, but I have that one memorized, so I started to write it. But you don't have to. Okay, now I'm going to do UT. U, T, U, T. Okay, are they the same? Nope, which means there's no way this thing could be a parallelogram, and I do not need to go through the hassle of checking the distance of the other pair of sides, because once I have one pair of sides not congruent, this thing isn't a parallelogram, because it has to have two pairs of sides congruent. Yeah. All right. That's all I had for you guys today. Thank you guys so much. Yes.